Hello, kiddos, and welcome back to yet another retro channel. Today, what you see on the bench is a Texas Instruments TI-99 4A. Now, in the recent videos on Copper Dragon's Lumicode boards, I installed one of his TMS digitizers under the TMS 9918 in one of my TI-99s, not this one. I don't know if I mentioned in that video, but I have three. The one that I modified, which was working when I got it, so that one was great. And I had two others that I hadn't even touched, hadn't even tested yet. So when I did the cleanup from that video, I decided to go ahead and test the other two machines and see what their status was. Now, one of the two machines worked. I opened both of them up, dismantled them like this. First, I tested the power board to make sure that it was providing the right voltages on the 4 pins here, 3 voltages, plus and minus 5 and plus 12. And all the power boards were working. And then I took the keyboards from the two machines and put them on the working machine that I modified and made sure that they worked. And the keyboards are all good. So we can go ahead and set these aside. However, what I did discover is that one of the two motherboards worked. So that one's fine. That machine is all reassembled and back together and ready to go. So what we're left with is this one. Now this one, the entire case is filthy. It's got debris and gunk inside. And what I've discovered is that it appears this one had something spilled on it. You can see that over on this side of the board. There is a lot of liquid damage, corrosion. The pins on the chips, you'll see, are oxidized pretty badly. Now, these are all, I believe, logic chips, 74 LS series logic chips. So they should be easily replaceable. What I'm worried about is that this machine was taken out of service because this spill maybe caused a short on the board. So there may be carnage on all these other chips. I don't know. So what I'm going to do right now is I'm going to start the process of cleaning this up. What I'm going to do first is I'm going to use a regular toothbrush and IPA to see how much I can get off of this. And then we've got some other cleaning solutions that we'll try if this doesn't do the job adequately. And of course, we will do a complete washing of the board as well. Now, I don't know what was spilled on this. I'm guessing at this point that it might have been cola because of the color here. If it was cola, cola is acidic, so I'll need something that's a base to clean it with, and I've got an idea for that. But we'll first try with just some IPA and see how much of this we can remove. Should have mentioned, when I tested this board, I just got no video output at all, nothing. It looks like whoever owned this did have some form of a sidecar expansion because there is evidence of wear on the expansion port. Okay, I don't know how well you'll be able to see this, but it appears that a lot of the corrosion is gone, but there's still some of it left. I think I'm going to try, like I said, I think an acid was spilled on here. So I want to use something basic to try to finish cleaning up. And what I've got is a slurry of baking soda, bicarbonate of soda, or sodium bicarbonate, which is a base. So hopefully this will help clear the rest of this corrosion and maybe stop any future corrosion. My other alternative is if this turns out to be a basic solution that was spilled on it, I will try an acid, which would be vinegar. But for now, I have to be careful with baking soda because baking soda is abrasive. So while I want to apply it pretty liberally, I don't want to scrub too much because I don't want to wear away anything important like traces. But I want to make sure I get in to the pins of these chips. And we will, of course, do the same thing to the bottom of the board if we need to clear any corrosion away down there. Corrosion or caustic results if it happens to be a base. I want to make sure I get in there good into these pins and then between these passives. Again, this will all go for a warm water wash once we've cleared the corrosion away. This board needs cleaning from more than just this liquid damage. All right, we're going to let that sit for a while and then we'll clear it away. And we'll come back in a little while and see how that's done. Okay, so I gave that about a half hour to soak, and then I took it and rinsed it off. And I don't know how well you'll be able to see this in the camera, but it does seem to have taken away most of the corrosion around the pins and the solder joints. So what I'm going to do is I'm going to flip the board over, and I'm going to apply the same treatment to the back. Starting again with IPA. And then moving on to the baking soda slurry. And then as before, we'll give that about a half hour. And we'll take it at that point and we will rinse it and we'll give it its full wash. Okay, and in preparation for washing the board, I have gone ahead and pulled the only 5 socketed chips. That is the VDP, the 9918, the 3 Grom chips, and the sound chip. Those are all socketed, and I've noticed something a bit annoying, so I thought I'd mention it. This socket and these 2 sockets are actually installed upside down. The only indicator, there's no notch on these sockets. The only indicator of pin 1 is this small white square. And these should be on this end, as they are on these 2 sockets. The VDP, the notch faces down. The Groms, the notches face down. So these 2 are correct, but these 3 are in upside down. So I've got to make sure I remember that when I put this board back together. But I'm also noticing there is some rust and corrosion down around these passives that I probably should take care of. So I'm going to do that and then wait and give the back side about a half hour so that it can soak in, and then I'll give this thing a wash. Okay, so the board has been washed. It still needs to dry, finish drying. I used air compressor to blow most of the water out, but that probably won't get everything. So I have to let it dry for a while. In the meantime, I have a handheld microscope here, and I'm going to take a look at some of those pins. So we'll go over to the microscope view. Now you'll have to forgive the shaky cam here. This is a handheld. There's still some corrosion in there, but maybe we'll get away with it. We'll see. We may have to pull some of these chips and clean up better underneath them. There's definitely still some corrosion in there. I'm worried that the corrosion might be electrically conductive and be shorting things out, or might have damaged traces, like there's one right there that I'm concerned about. Yeah, still some heavy corrosion around here. But once we wait for this board to dry out, okay, so we'll give this board some time to dry and then we'll come back. Okay, we're back. And I have given the board a clean. In fact, I've given it 2 cleans. After the initial scrub down with the baking soda solution and then the wash, I brought the board up here, plugged it in, didn't get good results, and I took a look, and some of the corrosion was still there. So I decided to give it a second treatment, this time with vinegar. I have some 75% vinegar, and I diluted that down and used it to scrub it some more, and gave it another wash and let it dry again. Now, I'm not expecting any better results here, just so you know, but we have it hooked up to video, audio, and power, and here's the power board. I'll give you a little closer look at the results of the cleaning and washing in a little bit, but for now, I just want to show you what this machine is doing. And what it is doing is more than it did initially. Initially, I didn't get anything out of it when I tried to power it on. Now, however, when I try to power it on, I get this. So we get a black screen and we get that annoying noise. Now, if you've watched any of, for instance, Adrian's Digital Basement's attempts to repair a TI-99 4A, or Noel's Retro Labs attempts, you'll know that the startup routine for the TI-99 4A says that the machine will go through a few steps and then it turns off the sound chip. So what's happening here is the sound chip, which is this chip right here, the sound chip is not being shut off. So it's not reaching that point in the startup cycle. There's all kinds of things that could be causing that. So we need to do some examination. Well, let's actually just pull up that startup routine. Hang on a second. So as you can see here, the system power up sequence for the TI-99 4A, power is turned on. The 9900, the CPU, resets and addresses low EEPROM locations. So the EEPROMs could be a problem. The 9900 initializes. The 9900 sets up workspace registers in the 6810 RAM. That's the 256 bytes, not kilobytes, bytes of static RAM. 9900 begins reading from the GROMs, so the GROMs could be an issue. 9900 enters into a time delay loop to allow stabilization for a quarter second, and then, and only then, is the sound chip turned off. So, potential issues we could have right now. Actually, we'd have way more than this, but these are the first few that come to mind. First of all, the 9900 itself could be bad. The 9900 requires a clock, so the clock generator chip, the 9904, could be bad. That's this one right here. The ROMs, which it tries to read, could be bad, and that's these 2 chips right here. And the static RAM the 256 bytes of static RAM that it uses as scratch space could be bad, or the 3 groms. Any of those 3 could be bad. Now the sound chip seems to be working because it's making the noise, though it could be faulty as well. So what I'm going to do, the next step, is I'm going to start trying to eliminate these possibilities. And the first thing, the easiest thing that I can do, is I can test the 5 socketed chips, the VDG, VDP, the 60, or the 9918. I can test it, I can test the 3 groms, and I can test the sound chip because they're in sockets in a working board. So I have a working board. This was the other of the 2 boards that I hadn't tested when I did the upgrade on the one TI-99 4A that I had that I knew was working. So this is the second of the 2 that I hadn't tested. And when I tested it, it worked perfectly. So we're going to hook it up. And the first thing that we will do is test to make sure that it is working still. And it is. Now you're not hearing sound because the RetroTank didn't refresh itself in time. Let's see if I can get some sound for you. Still nothing. Well, I can't get the RetroTank to refresh in time for you to hear the sound. What you would have heard, if it had been fast enough, was you would have heard a tone like we heard on the dead board for just a split second until the machine started up, and then that tone, or that odd tone, would have stopped, and there would be a distinct beep that lets you know that the computer is working. Okay, so what we can do, like I said, is we can test the 5 socketed chips. So this is the dead board. I'm going to go ahead and pull those 5 chips, noting that all those 5 have their notches facing the bottom of the board. I want to mark these groms so I get them in the correct order when they go back in. Give me a moment. Okay, there are the 3 groms. And last is the sound chip. Now we will test these one at a time because if multiple of them are bad, we don't want to miss anything. So the first thing I will test is the video chip. Here's the good video chip. And here is the video chip in question. Again, notch goes to the bottom. Okay, do we have a good video chip? We do indeed. So that's a good thing. So our video chip is good. All right, we'll try grom, what I'm going to call grom number 1. Is the first grom good? It is. Okay. Second grom. And the second grom is good. Third grom. And the third grom is good. Sorry. I can see it up on my display before it comes up on the capture card. So all 3 grums are good. Now we need to check the sound chip. This is, yeah, just making sure that I got that grum back in properly. Now we'll pull the sound chip. And there you heard the sound. So you know the sound chip is working. All right. So these 5 chips are all definitely good. Bye-bye to the good bird. Make sure our problem wasn't a miraculous dirty socket issue. And we're exactly where we were. So I'm going to take a break and grab some dinner, and we'll be back shortly. Well, I'm back, and that was yummy. So it's time to start actually doing some probing and checking some signals and seeing what's working and what's not. So we have the board hooked back up. I have my multimeter set to DC voltage because the first thing we need to check is the power rails. Now we know that the power board itself is working because it works for the other board, and we are getting something because we are getting that that sound and the black screen. But I don't know what everything on here. I don't know that the power is getting everywhere that it needs to on here. So it's time to start checking some things. So I'm going to power this up. Now I don't have the sound hooked up, so you're not going to hear the annoying tone the whole time that I'm doing this. But I'm going to put my ground probe on the ground plane, and this is where the RF shield connects. So this is going to be ground. I can verify that by checking it with ground pin, which I believe is continuity. Check that to make sure with the ground pin, which is right there. So yes, this is ground. Go back to DC voltage. And again, start with the ground probe on the ground plane. And I'll start checking at the memory. Now, these memories are 4116s, which means they use +5, -5, and +12. So I should be able to detect all 3 voltages on these RAM chips. Pin 8 should have 12. I'm just reading the schematic or the data sheet wrong. So pin 8 does have 12. +5 should be here. And it is. And -5 is pin 1. Oh, there we go. Okay. So if I'm reading, if I read the data sheets right, the voltages are there. Okay. Let's go back over to the scope, and we should be able to see our clocks. Our 4 phases of 12-volt clocks. This system has 8 clock signals. There are 4 12-volt clocks for the CPU, and there are 4 TTL inverted clocks. I'm not sure at this point what those run, but we need to check all of them. And they're all generated by this 9904. So pins 12, 11, 8, and 9 are the 4 phases of the 12-volt clock. Pin 11. No? Oh. And it wasn't right down here. 11. No clock. 12. 8. 9. Huh. All right, let's try 14, 15, 7, and 6. 14. No clock. Okay. I pulled the working board back up onto the bench and I tested the signals for the clock input to the 9904 on that board, and I was getting the same readings as I was on the bad board. So since I'm not getting any clocks out of the 9904, I'm going to try replacing it. I think that's a good bet at this point, and I do happen to have a replacement part. Now, there is a caveat to doing any desoldering and resoldering on the TI-99 4A, and that is that TI didn't put solder mask on traces that run between vias. So anytime you do work, you have to make sure that you don't bridge to an exposed trace. You can either be very careful with that and double check your work, or what I may go ahead and do is once I get the chip desoldered, I may go ahead and use some UV curing solder mask, or conformal coating, whatever you want to call it, to protect those traces before I go soldering in the new chip, or the socket in the new chip. So let's go ahead and take out the 9904. This guy right here. So I have pulled out the old 9904. In the process, I broke a capacitor, so I had to replace that. It was a 1 microfarad, 0.1 microfarad capacitor. It's like a decoupling gap. So I had to replace that, and also I was out of 20-pin sockets, so I had to use a 14 and a 6 to provide the right socketing. I also did, as I said, use some UV curing conformal coating or solder mask to protect the few traces that did go between the vias for the 9904. And here is the replacement 9904 that I had ordered just in case. Didn't cost much, so I went ahead and ordered it. And this is a desoldered chip, so we got a little tidying up to do the legs. Hopefully this will work. I don't know. It's never been, or I haven't tested it. Okay. And let's see if we get anything. Nope, same thing. Okay, so that didn't fix the problem. So let's do a little more probing. See if we're at least getting clock signals now. Okay, so I did more testing and I could never get this chip, the replacement, to give me a 3 megahertz clock. It kept giving me a 750 kilohertz clock. I finally took a closer look at it and noticed something that I didn't notice before. When I ordered this, I believed that I was ordering a TI-9904 A&L, the four-phase clock generator. However, what I actually got was a TMS, not TIM, a TMS 9904 A&L. It didn't occur to me because TMS, for instance, the CPU is a TMS 9900. But I don't believe this is a compatible chip. Now, luckily for me, took a shot and I put the original TIM 9904 back in. Now that it's socketed, may have been a bad connection issue, may have been a corrosion issue, whatever it was. Now that I put it back in, I am getting a 3 megahertz 12 volt clock on all 4 phases. And a 3 megahertz 5 volt clock, TTL, on all 4 phases. So let's check the clock on the CPU. The clocks are 8, 9, 28, and 25. Pin 8, 1, 2, 3, 4, 5, 6, 7. Pin 8, 3 megahertz. Pin 9, 3 megahertz. 28, 3 megahertz. And 25, 3 megahertz. So we're getting all of our clock phases. Well, I'm afraid this video is getting a bit long, so we're going to have to break it up into 2 pieces. So keep an eye out for part 2 of the TI-99/4A repair. I do have to apologize again for the technical difficulties with this video. I'm pretty sure I have the camera wobble fixed. That echo, I'm not even sure where that came from, so hopefully it just won't happen again, or I'll be a little more vigilant in what I'm recording. And the static that you heard through the second half of the video, I'm trying to deal with that. I think I may have to replace my microphone setup. Hopefully I can get that dealt with, and that won't be an issue going forward. So, all the usual stuff. If you like the video, give it a thumbs up. If not, you know what to do with that too. I'm willing to take negative as well as positive feedback, whatever you need. And leave me a comment in the comment section below. That's another place that you can leave me anything, positive, negative, or neutral. I love interacting with you guys. Being a part of this community is what this is all about for me. Share the video out to as many people as you can. The more people that see it, the better. See, if you haven't subscribed already, please go ahead and do that. And if you'd like an alert when I post a new video, just click on the notification bell. And if you'd like to support the channel, there are now 3 ways that you can do that. There is Patreon, which the link for that is showing up on the screen now. Another way would be Ko-Fi. You can donate that way. Or you can become a channel member. That link is somewhere right down here. Click on that and you can become a member of the channel. There are perks for members, for supporters. Early access to videos. Once I have enough members to make it worthwhile, there will be members-only videos and possibly even members-only live streams, supporter-only live streams. So keep an eye out for those once you join. Alternate ways to stay in touch with me or to interact with me or the other members of the community. I do now have a Discord server. The invitation link is showing up on the screen. And I also have a Facebook group, so you can join the community that way. So all that being said, I will now sign off, and I'll see you on the next video. So everybody, in the meantime, stay safe and be well. Take care of yourselves. Have a great week, and we'll see you then. Bye.